Now I am going to explain you the congruency rules. After understanding these rules, if you try the problems that I have given in Reasons Review 4 Part B, it becomes very easier for you. That's why first let us focus on these congruency rules. We have actually 5 rules, I can say. First one is triple S, second one is SAS, third one ASA, and fourth one AAS, and the fifth one is HL rule. So what are these rules? Let us see one by one in detail. So first one is SSS, rule of congruency. You see, if you take two triangles, here he is saying AB is congruent to DE. That means this AB is congruent to DE. They are equal. Congruency means BC is EF. This BC, the second side, is equal to second side of this triangle, and then CA is congruent to FD. That means this third side is congruent to this third side of the second triangle. Whenever you have two triangles, the corresponding three sides are equal to the corresponding three sides of the second triangle, then we can say that these two triangles are congruent by triple S rule. That is, this rule states. Next, if you see the next rule, SAS, that means side angle side. So in this triangle, BC is equal to AF. That means this BC and EF are equal or congruent. Then CA is equal to FD. This CA and FD are equal, and angle C is congruent to angle F. That means between these two sides, this is the angle, and between these two sides, this is the corresponding angle for this. So whenever in two triangles, two sides are equal to two sides and the included angle between them are equal, we can say that these two triangles are congruent by SAS rule. That's what this rule states. Next, we have third one, ASA. That means angle side angle rule of congruency. So in these two triangles, this angle Q is equal to angle L, angle R, that means this angle, is equal to angle K, and QR, LK are congruent. QR, that means this side, is equal congruent to LK. That means whenever two angles and the included side are respectively equal to the corresponding two angles and their included side, then we can say these two triangles are congruent by ASA rule. That means angle side angle rule. Next, if we see the next rule, that is fourth, angle side rule of congruency. That means here angle H is equal to angle H, like this, and angle A is congruent to angle S. AN, this side, is congruent to SC. Here two angles and one non-included side, two angles, the corresponding angles, and one corresponding non-included side. Whenever they are equal, these two triangles are congruent by AAS rule. What is the difference between ASA and AAS? Here the side is there in ASA, we have the side is included between the two angles, but in this AAS, this side is not in between these two equal angles. That is the difference. So angle side, angle side. All right, next rule of congruency is HL, hypotenuse leg rule of congruency. So in these two triangles, here angle ABC is 90 degrees, angle DEF is 90. That means these two triangles are right triangles. So this HL basically a congruency rule in two right triangles. That's why these angles are 90. So whenever if you take two right triangles, AC is equal to DF. That means hypotenuse. This AC is opposite to 90 degrees. Therefore, this is opposite to 90. That's why it is called hypotenuse. And DF is also called as hypotenuse for this triangle because it is opposite to 90 degrees. So these two hypotenuses are equal, and also one leg, either this or this, must be equal to either this or this. Here he is saying AB is DE. That means this AB is exactly equal to DE. So these two legs, corresponding legs, are equal, and these hypotenuses are equal in these two right triangles. Thereby we can say these two triangles are definitely congruent by this HL rule. So one more time. So in two right triangles, the hypotenuses are equal, and also one corresponding legs, if they are equal, we can say these two triangles are congruent by HL rule of congruency. Like this we have 5 rules of congruency. Now if you see your packet, in this reasons review for part B, we have done part A, the proofs. After that part B, these are also congruency problems but multiple choice questions, both in the common core as well as in the regular reasons exam of 2005 standard. We get congruency problems. So in this, first one is, he's saying triangle congruency, determine the congruence of two triangles by using one of the 5 congruence techniques: SSS, SAS, ASA, AAS, HL, given sufficient information. Okay, let me show you the second problem first. I can show you 3 or 4 problems, the remaining all you can do by yourself. So this is how we do these problems. First one is, the second one here, as shown in the diagram below, AC bisects angle BAD and angle B equal to angle D, he is saying. Which method can be used to prove these two triangles are congruent? See, one more time. AC is bisecting angle BAD means this is the bisector of this total angle. So this part is equal to this part. If it is total 60 degrees, this is 30 degrees and this is 30 degrees. Like that, they are equal. One angle is equal. And in the problem itself, it is given angle B is congruent to angle D. So we got two angles equal. Nothing else he has given. And with your common sense, you can understand in this triangle AC is there, and in this triangle AC is there. So AC equal to AC by reflexive property. Therefore, if you see angle this side, angle this side, that means AAS rule permits that these two triangles are congruent. So SSS is wrong, AAA is wrong, SA is wrong. So AAS is the only answer. How do we believe that we have done correctly? So for your facility here, I am giving the answers at the end. So if you see, all the answers are given on the last page of your worksheet. Don't copy the answers as they are. You have to do in this way how I did now. So I did second question, I got 4 here, and when I check my answer is also 4. That means I am correct. Even if I am wrong, I can correct what is the correct answer and I can understand. That's how you have to study. So this side, this is over. I want to show you one more problem, that is number 6. Let me read first. The diagonal AC is drawn in parallelogram ABCD. Which method cannot be used to prove that triangle ABC is congruent to triangle CDA? See, he is saying parallelogram. So I am drawing parallelogram ABCD. Whenever they do not, if they give figure, that's fine. If they do not give the figure also, you have to draw the figure so that you can understand the problem quickly and you can solve very easily. So he is saying AC is drawn in this parallelogram, he is saying. So the diagonal AC means like this. If I join, I can draw. Which method cannot be used? Cannot be used, he is saying. See, opposite sides of parallelogram are equal. So this side equal to this side and this side equal to this side. So in these two triangles, these two sides are equal, and also the third side is common for both the triangles. Therefore, SSS rule can be used to prove that these two triangles are congruent. But he is saying not be used. So this is not our answer. In the same way, whenever this side and this side are parallel, then see, when these two are parallel, this is a transversal. So this angle is equal to this one, And if you see these two sides, these two are also parallel, therefore this angle is also equal to this one. So if you see carefully, angle side angle are equal to angle side angle. ASA rule is also applicable, but it cannot be used. This if we can use, but he's saying not to be used. So this is also a wrong answer. And if you see this side angle side, in the same way side angle side, SAS rule also permits us to prove, but we want not be used. So this is not the correct answer. So the correct answer is SSA. You remember, we don't have SSA rule at all. So this is the answer. This frequently they give in the exam under the congruency problems. If you see SSA, there is no rule of SSA, but that is the answer here. So let me check whether I am correct or not. For 6 I got 3, and what is the answer there I can verify. So in the same way you have to do you too. So in the 6th question I have 3. That means I can say that I have done correctly. Next, let's see question number 9, which I did even in the class. Anyhow, A, B, C, X, Y, Z. Which statement must be true, he is saying. Here angle C is angle Y. Angle C is the third letter is G. But he is giving Y, that's why that is wrong answer. I am erasing that. And next, if I see angle A, angle X. Oh, A is first letter, X is first letter. It seems this is the correct answer. Anyhow, I verify AC, YZ. AC is first letter, third letter, XZ. But here YZ is given, so that is wrong. And then CB. CB is third and second. It should be ZY. Third and second means ZY. But here XG is given, so this is also wrong. So I confirm the answer is 2 here, but I don't know whether it is correct or wrong. So I can verify for you. When I see the answers, question number 9, I got 9 too. That means I am perfectly correct here. Next, if I turn the page, I have no problem here to do for you. And here I have the last problem under this category. Triangle ABC is congruent to triangle JKL. That is congruent to triangle RST. Here 3 triangles at a time they have given congruent. No problem. BC must be congruent to what? Without seeing the answers, first I will say, where is BC? BC is, B is second letter, C is third letter. Here second letter is KL. Here second letter and third letter KL. And here second letter and third letter is ST. If I search for KL, I am not finding here. If not KL, I have to see at least for ST. ST is not here, and JK here, and this is RS. So ST is in the third one. So for 17th, the third one is correct. And again, you can verify the answers. Here, even in the 17th, I got 3, so I'm correct. So in this way, after doing, then you have to verify. If you go wrong, you can tick correct answer. In this way, you have to complete this homework. Thank you.